Hi and welcome to DCO. My name is David Copetti, and in this video I'll be sharing with you how to create this shade structure. We'll be starting with the base geometry, which is going to be a circle. Then we split it in a few other ways, like here. And then we move on to creating the base arc, which we start with a straightforward arc. Then later on we remap the numbers and go over some techniques that we can use for any design. This one in particular, we can play around with so many of the parameters at the end, but the basics are really where it's at on this one. So I'll be sharing with you all of those things here, and thank you for being here. If you want to support my work and access all of the scripts that I make for this YouTube, check out my website copettidavid.com. When you become a Script Vault member, you can access all of the videos from the past and all of the future videos, and also get in touch with me. I have other resources like being able to learn Grasshopper, Script Store, and a few other free resources on my website, so if you haven't, check it out. Thank you very much for being here, and let's jump right into the tutorial. So first thing we'll do is open up a new Rhino file. I'll type in here units, and we'll be working with feet. I'll hit OK. And now we can start here with a new Grasshopper file. And the first thing we'll do is look here under display. I'll have draw icons, draw fancy wires, and draw full names. And with that, now we'll get started. We'll start by constructing a point. So we'll go here to construct point. Then we'll route that through a point component. This way we were able to change the location of where we have the design. So we'll go from this point. Now we'll be creating a reference plane that is in the X and Z direction. And this is how I visualize it, is I go here to the bottom left of my viewport and I have the X, Y, and Z here, and we see that X positive and Z positive. We'll go X, Z plane, and we'll plug that into the point, or we'll plug the point into the origin. And now we'll use that plane to create our circle. So we'll go here to circle. As you can see, when we bring in the circle, it actually has the default plane, which is going to be the X and Y. And this is why we created the XZ plane, so we can plug that into the plane input. And now the radius we can change. So let's go here to 15. What I'm going to do is disable the preview on the plane so we don't see that plane here. And now we can move on to creating the base geometry. Now what we need to do is take this line or this circle and offset it to the inside and to the outside. And the way to do this is first we'll change the name here to structure size. I'll make it all caps for mine, but you can do whatever you want for the naming. So structure size. What matters the most is that you're able to understand what it changes. Everyone has a different preference, so and there's no real standard for this. So we'll go here to offset curve, and then we'll take this circle, we'll plug it into the offset. Automatically, it gives us an offset of 1 on the default plane, which is going to be, well, the circle already has a plane, so we could either plug that in here into the plane or just leave that without one. Either way, it's going to work. The distance is going to be by how much. So we'll say 1.5, 0. This way we have 2 decimal points, and it gives us a little bit of more room to change and see the design change. We'll go 1.5 on the distance here, and then I'll go here, create a copy, and then do a negative component, allowing me to then offset this not just to the inside or to the outside, but also to the inside. So this is going to be structure size 1 or 2. Structure offset. And we can always change the name. It's just for now. We have these. Okay, so now what we need to do is create a plane in between these two. For that, I use boundary surfaces, which is a component that will create a, like it says here, when you hover, it says create a planar surface from a collection of boundary edges. But when we plug them in, so let's plug this one in first, and holding down shift, we'll add another one. So this one just worked automatically, but typically you do want to kind of flatten the input. This way you kind of create that surface in between. But now that we have that, what we need to do is split this surface into the ground plane, because this technically won't be able to, you won't be able to develop it because it kind of, the lowest point is just one small point. This way we can just, so the next step is going to be to split this at a specific height. So to do that, we need to create a line. So we'll go here to this outside offset. Then we'll go here to endpoint. And then here we have a start and endpoint, which are the same. And what I want to do is bring in the midpoint. This way we can create a line from the start to the end, which is going to be the midpoint. So the diameter length. So I'll go here to line, component between the start point and this endpoint. And now with this, we can split this surface. But the only thing that I would do different is I want to have the ability to move this up or down, but mostly down, because when we move it up, actually from this point up, it's going to split the arc in two. So let's do this. We'll take a move component. We'll be taking this line or this geometry, bringing it into the motion unit Z, and then negative. Why? Because we actually want to move this down. So move this down, and then we'll give this a value. We'll say 1.50. And then here, change the name to structure split. So this is going to determine where, let me show you here. So I'll disable the preview on the line and both the midpoint and the start and end point. And now with this curve, we're going to bring in surface, split, and we're going to take this surface and this curve that we moved up and down, and we're going to split it. What happens is we have two fragments, right? Because it's split it into two through this curve. Now we only need to pick one of them, because here we have two outputs. So every time we want to pick one of the items inside of a component, we go to list item. And as long as they're coming in not dashed lines, which means grafted or in individual groups, then in here we can go index of 0. And if that's not the one we want, which we don't, we want the one on top, we go here to list and reverse. And this way it always picks index of 0, which is the list flipped backwards. It picks that one first. So here we can move this up and down. And if it looks funky, it's because we have overlapping geometry. So let's take this one, and this one, oh, not this one, and disable the preview. The way I do it is middle click. And then there's this guy that's blindfolded, disable preview, or you can also right click on each component and disable the preview on each or enable it. So with that, we have our base geometry that we're going to be using for our design. Next thing we'll do is split it down the middle and then have to kind of recreate some of those geometries. And so we'll be going over all the steps right here. All right, so let's take this surface. Now that this is the leftover surface, let's go back to this curve before we moved it down. So let's go up to here. Now we actually need to take this curve, which is the one here in the middle, and split this new one that we have selected from this first split, which is going to be the ground plane. Now we're going to do a surface split once again, but this time using, like I said, this surface, and then using this line segment as the cutting one. And so we're going to be doing the same thing, which means to select, or let's remove the overlapping geometry. So all of this, middle click, disable preview. Now we're going to be taking this and going to item or list item. And with this one, we'll take this, plug it into the input, and we'll be taking a different approach on this one. On this one, I showed you how to kind of use the index and reverse it. But here, I'll show you how to add. So the list item, one of the cool things that this component has is you can add more parameters, which means that if under the list here, we have 3 values, I can add 1, 2, and 3 outputs. In this way, I can use those individually by using a surface component. And this will be this bottom left one. We'll copy this. Going to be bottom right, and then this is going to be the top. Now I can disable the preview on all of this, and we can look at these individually. Here's the thing. Since this is an like a circle, we can technically just do one side and mirror it to the other side. So I'm not too worried about having both of these separate. What matters is that we're going to take this surface. We're now going to be moving it to one side and extruding it by twice the depth. So what we'll do is take this. I'll go to move. It's going to move it up by default. So what we want to do is actually move it in which direction? In the X positive Y, and then we're going to extrude it by negative Y. So we'll go here to, or it could be negative Y and extrude by positive. So we'll go here to unit Y. We'll be moving it in this direction by 1.50. So we'll give it a specific value here. And now we'll go extrude. So the trick is to take the surface, rather than extrude it, we'll move it and then extrude it by the same amount, but then twice as much. So we'll go here to negative. And then times 2. So star 2 or x2, which will give me a empty parameter for A, and for B, we have 2. So now it's going to do that negative. Now we can extrude this by twice as much. Now I can disable the preview on all of this, because the next portion, we're now going to be taking this rectangle here and be arraying it around to create kind of that form. But now let's take this and let's actually go to our midpoint, our original point, and that we'll use to create a YZ plane, which is going to be our mirror plane. That mirror plane is we'll use for a mirror input, and then I'll bring this all the way over here and plug in this into the geometry. And so now whatever we do to one side, it will do to the other side, and we don't have to, and it's actually easier for the computer to do that. But not that we're even doing too much, we're just doing one form. So with this and that, we'll plug those into we'll leave those there for now. Now we'll focus on the next portion. So now let's go back to this line, which that line is what splits this surface, right? And so where this line overlaps with the surface before we cut it, which is this one, where these two overlap, I want to extract a curve, because that's what I want to use to extrude and use as my base surface. So we'll go here to the intersect tab, physical, brep with curve, bring this down. And I'll be using this as my brep and this line as my curve input. Now instead of selecting both of them, I'll be selecting just one. So I'll go here to item or list item, and I'll just pick one of them. Whichever one, because it doesn't really matter, we can mirror it anyway. So we'll take this and we'll be extruding it in the Y direction. We'll go here to extrude. So this line segment that overlaps with that, we're going to extrude in the Y direction. By how much? Well, we know that we went 2 times this amount. So halfway, it's only going to be here in the Y direction, and we'll use that input for this. So this is symmetrical also this way and this way. So we only need to create one segment here to create the form that we're trying to go for. So we'll take this, plug that into the curve input. Why? Because I only want the outer edge of that surface, and when it's a planar surface, you can literally just plug in that component into a curve and it will give you the curve outline, right? And it gives it to you as one polyline. This way we can now array this throughout this this curve. What happens though is that if we take a look at that curve, which is actually our original line, well, we have an entire segment here and we only need a segment from this side all the way to this side. So if you haven't noticed, one of the tricks that I like to use is intersecting geometry to extract information. So we have this overall line and we have this segment of this surface segments that are overlapping. If I go here to this surface here, it starts here and it ends here. And now if I go to a brep curve, so we'll go brep curve, and where those two intersect, so I'll take this as my brep, where the curve, which is the original, where they intersect here. Now we're going to go to this curve, and we're going to do an array, curve array, and array this geometry through this curve. And we can pick the number of segments. So we'll go count 5. Now we can take this, and just to see what that looks like all together, we'll go to Loft. And yeah, technically we've recreated that. And the more segments we have, the closer it is to the actual curve. What we're going to do now is with these segments, we're going to change the size of them and move them. This way we can make it more of a dynamic design. But let's go back also and let's play around and change some of these parameters. Cool. So let's now move on to that next portion. I'm going to go over a few techniques that will be super useful for changing a set of geometries here to make it more dynamic. So let's go over that. Okay, now let's take this lofted portion and let's just delete it. We're going to be taking these segments and scaling them relative to a graph. So what we'll do is we'll take this, we'll go to an area component, because each one has to be scaled relative to each center point. So we'll take this geometry, plug that into the geometry for the area component, which will give us the centroid, which is the center point of that rectangle. Now let's go here to a scale component, which will allow us to then scale those geometries relative to, and as you can see, when you don't plug in a different centroid, it's going to scale them all relative to the center point of the default, which is going to be 0, 0, 0. So we plug in all of these center points, so it uses those as the reference to scale from. Now for the factor, well, we can go here to 1.5, and we can see that we can already plug in a value, but we only have one value. And so the trick to get this to scale up to a large value in the middle and then down to another, to the same value that it is, we need to take this, all of these, and graph them according to when you graph them according to a sine wave or a specific graph, you're able to change it, change those values. So let me show you without kind of talking so much. Let me show you. If we go here to a graph mapper, which looks a little bit intimidating, but is actually super useful. So by default, it comes with nothing. So we'll right click here, graph types, and we'll go to sine. Sine wave, what it does is it kind of gives you this sine wave and it plots values through this graph to change the scale value. So what we need to do now is go here to a range, because we need a range of points, specifically the exact same of points that we have for this. So we'll go here to range, and steps will go to the same number as the count. And so we see we have all of these lines that represent the different steps, that if we now plug this into the factor, we'll see that it turns red because we have this at the bottom. So if we raise this, we'll see that we have this small to large, and that's good and everything. But what happens is we need this to be at 1 and this to be more than 1. So for that, I like to, and to be specific about the number that I'm going to pick, I like to use something called a remap numbers. And so this part is a little bit tricky, but it does come down to practice. I do this all the time, so you'll see me like, oh, why is he doing that? Well, a lot of these things you'll just have to do over and over again because it's kind of the process that you take for doing specific things. So for for remapping numbers, we're going to bring in 3 different components all at once. Remap numbers is one. Bounds is another. And the third one is construct domain. These 3 always come in together because to remap your numbers, you need to first know all of your values, which are these. Then all of the values with bounds, it gives us the biggest and smallest number. So we can now use that as our source. And to construct from, let's say, to construct a specific number, so we'll go here to 1.5. And we'll have 2 different values, so we can construct it from this number to this number. The domain goes into the target. And so this is what I always do. When we're scaling, we typically go from 0 to 1 is going to make it smaller. From 1 to 2 is going to make it larger, and at 1 is going to stay the same. And so that is for scaling, but for moving things, it's going to be a little bit different because the value that you use is the exact amount that you're going to be moving it. Okay, so now that I've gone kind of over that, let me show you what really matters the most about this, is that the initial incoming value is 0.1, 0.19, and 0.4. So we have 11 values coming in, and they're all smaller than 1. Now we have remapped them with this. And now they're giving us the values. So the input was that, and the output is going to be 1.07 up to 3. So now we're saying that we can pick this map number, change the factor. If we go here to 1, it keeps, so let me show you here by selecting this, it keeps this at 1, which is the same size as it was originally. And then here, we're able to change the scale as it goes to the center. Now, the importance about this is we don't even necessarily have to do it with scale. We can do it with offset. We can do it with rounding off the edges. We can do it, pick a different, many different methods to create different geometries, but I'm showing you the most efficient way of doing this. So then later on, once you know some techniques, you can then apply those to many other designs and then have a lot of fun using this method of modeling. So with that being said, we'll take that and we'll loft it together. So here at the end, it's actually giving us an extra. What it is the range of steps is giving us 10, but we actually have 11 objects. So what happens is when I use 10, that is not correct. We have to do a plus 1, giving us 11, or it might be minus 1. Let's go here. Yep, it's going to be minus 1. Okay. So my apologies on that, but once we get that little adjustment in, then we're able to see, and that's the other thing, is you'll be able to see if there's an issue. And usually when there's an issue, it is the code that is broken because the computer's just going to do whatever you program into it. So with that being said, let's move this around. And we can even make it smaller too. So I think that actually could sometimes be cool here like that. So 0.5 is going to be half the size of what it was before. And then 2 is going to be twice the size of what it was. And then here we have, if you recall, by default, we have our XZ plane, which means that we can mirror using this plane as our mirror plane. And this loft, which I like to cap holes because it's not going to be a solid. So I'll disable the preview here and then use that as the mirror plane. And I feel like that looks really cool, but the last thing we'll be doing is taking this geometry, and rather than it just scaling down here, we're actually going to be moving all of this to the right and create some kind of shade structure. So like when you're standing under this, you should be able to be covered. So let's go over those steps. What we'll do is disable the preview on this, which is going to be all the loft and the mirror plane, because we need to recreate that loft. And the way to recreate it is going to be, okay, we scaled it, but now we're going to scale it and move it to the right. Maybe the scale is too much, so we'll go 1.5. And then move this to the right. Now, here's the thing. We can move it a specific value, but it's going to move them all the same. Or we can take these values and remap them again, but to a move component. And so the reason why we see 2 here is because we have our originals. So I'll disable the preview on that. And now we can take these and move them to the right. So we'll go here to move. We'll move these in the Y direction. Look here. But rather than using one value, I'll take all of this, copy it down, and then use these remap values as the move. So it moves them by nothing here at the beginning. We'll go here by 1. Actually, so here by 0, and then here and the reason why is because since we're using a move component and not a scale, when we move by 0, well, that means that this moves by 0 and this moves a maximum of 3 feet overhang. So this would be the overhang. Now I can disable the preview on this and plug these lines into the loft component, which gives us this. And therefore, if I disable the preview on all of this and bring back our mirror and app, now we see that we can change these values here to meet our whatever we want for our design. But now at this point we can disable the preview on, I keep saying that, on all of this stuff, including the stuff at the beginning, and even these points here. Now I'll go to, and lastly, okay, now that we have this, we're going to deconstruct both of these, get this outside curve and create that surface between those two. So we'll go here to list item. And the thing is, when you have a list item, you can't just plug in, let's say, this brep in and be able to pick anything. We need to go here to deconstruct brep, which will basically explode it into the different things that it has. So it has faces, which are the surfaces, edges, which are the lines, and vertices, which are the points. We'll be using the edges as the input. And now I'll use an index and change the value using the slider. I'll reverse. Now we'll leave it like this. So the 9th curve is the one that I want. Now I can disable the preview on this and do that again, but for the other one. Let's see if it works with the item 9. With this one, actually, that's going to be the brep to plug in. The edges, the 9th edge, that one, and this one. Perfect. Now that I was able to select those two, we'll go to Loft and select both of those. What happens is this one and this one, they're both flipped over. So we actually have to flip curve direction. Now we can use the Loft component to create that surface between those two. Let's go back here and let's change. Let's also be aware that this is going to be the size, the amount that it's going to go out by. So we can also do some funky stuff like this. So when you have this graph, you want to visualize the center point, and it's starting and ending here, and you cannot. Yeah, I think that one is fine. Just before you couldn't have, since we remapped it, it's fine for it to be down here now. And if you want to get crazy yourself, I've kind of, for the most part, completed the tutorial. Just want to show you a few more things. If you don't like this, there are other graph types like Bezier, which means it starts here and it ends like that. But if we bring it down like this, we have some kind of control points that we can use. I think that's kind of cool. Right? And then back here, so different graph types, play around with them. Sign. This one it's kind of artistic like this. More, I like to keep it straightforward because for the most part, the concept is what and the technique is what matters. Then later on, you can come up with whatever design you want. And with that being said, hopefully you found that interesting and useful. Thank you very much for being here, and I hope to see you next time.